Hey guys, so this is part two of the Northrop Grumman handover ceremony for the vehicle assembly building and the mobile launch platform, which is right behind me. This is mobile launch platform 3 from the shuttle program, and it was it was launch platform 1 for the Apollo program as well. So there is a subject matter expert here, and we're gonna go on over and we're gonna take a listen.
If you want to do mine, John, that's fine, but I figured it would hang over there. Sorry, John.
Ken, sorry.
Video. Okay, first let's get your name and title and spelling.
Good morning, this is Jerry Close. This doesn't sound Jerryclose, Close. And I'm the Northrop Grumman Program Manager for OmegA for standing up and recurring operations of the OmegA launch program here at KSC.
When will you start officially using the VAB in the high bay? Do you have a date?
So what we have is the non-recurring modifications to the VAB, High Bay 2, and we're expecting to start those in early 2020. There are not many modifications we need to make to the High Bay, so approximately 6 months of modifications inside High Bay 2. So most of the work is actually behind you on MLP3. So for MLP3, we're adding a 330-foot tall steel structure. It's a 36 by 36 footprint with elevators, with umbilical booms, with wind stabilizer, access platforms. Actually, we'll have a vertical translating platform systems. So everything will be supported off the mobile launch platform and umbilical tower on the mobile launch platform. So it's actually the MLP3, when we're done with our modifications, will much closer resemble the original MLP3 for the Apollo program, for the Saturn program. So it'll have the tower will be approximately the same height. It'll resemble pretty close to what the current SLS MLs look like.
Because you're retrofitting it for a rocket as opposed to a shuttle.
That's correct.
A little more similar,
for a much taller vertical integrated rocket, yes.
What
All designed already? We're finishing up the design. We have the major steel is out on the street for fabrication, and so we're expecting a lot of the steel to arrive within the next couple months. Once we finish the final demolition of the base, we'll start the erection of the new tower.
what is going into that demolition?
Excuse me real quick. That'll be, so the work is going on right now, so as soon as the steel's ready, actually we will have some steel out probably within 3 months here. You'll start to see the tower climb into the sky.
And what's going into the actual reconfiguration of the base for the MLP?
So the base, the shuttle configuration had an opening for the orbiter, and then it had 2 openings for the solid rocket boosters. So we're actually filling in the solid rocket booster openings and putting a single center hole, again, similar to the Saturn program, Apollo program, because that better accommodates our single stick OmegA configuration. That'll be for the intermediate and heavy. So along with that is all the mechanical and electrical systems to support the customers' equipment, be it the Air Force or commercial customers, as well as the water deluge systems, the electrical power distribution, pneumatic gases. I mean, anything that we're interfacing with, the mobile launch platform interfaces with at Complex 39B, which are going out to 39B, will interface with the MLP, be delivered through the MLP, regulated, distributed up the tower to the umbilical booms, ultimately to the vehicle.
What's the progress of OmegA OmegA. How's it going? And what have you discovered from the anomaly back in May?
Yeah, I'm going to defer to Trina for that. I'm really taking care of, responsible for the ground systems here, as well as standing up the operations. So we're of course, we just finished up our launch vehicle CDR this past week in Chandler, Arizona. So I actually flew in late last night.
What's the CDR?
Critical design review, excuse me for that, yeah. So the vehicle is progressing along, and we're ready, ready for pathfinder activities and ultimately the first flight hardware sets that'll come down here to Kennedy Space Center. So we're putting together all the procedures, working with all the respective subcontractors, including the NASA, TAS, and BOSS contractors out here. So we're very integrated into the KSC campus here, not only with the hardware, shuttle era hardware that's modified for OmegA, but also the existing contracts that NASA has with the support contractors.
Once the OmegA rocket is fully operational, you've had all your tests and all of that, could you describe kind of the sequence of steps in building up the rocket in the VAB, what comes when and then how it gets moved out?
Yes, a good question. So we're using Heritage shuttle facilities. Behind the MLP3, you'll see that's the rotation processing surge facility. That beige-like metal structure. Inside there are two 200-ton cranes. The solid rocket motors are delivered from Canaveral, Utah, just like shuttle program, just like SLS program, into the rotation processing and surge facility, and they're lifted out of the rail cars and broken over vertical. So depending upon the either intermediate or heavy configuration, we'll have anywhere from 3 segments coming through the RPSF to up to 5 large segments coming through the RPSF. So that's the first second stage. So OmegA is a 3-stage rocket. So there's both the first and second stage are solid rocket motors, our Castor 600, Castor 1200, and then the Castor 300 is the second stage, with a liquid upper stage as our third stage. So the solid rocket segments come to the RPSF, break them over vertical, then they're transferred over to the transfer aisle of the VAB and lifted up with the big overhead crane that you saw, lifted up over into High Bay 2 from the transfer aisle, and then stacked onto our mobile launch platform 3. So that's a serial sequence. First stage, either 2 segments or 4 segments, and then we have between the stages is the interstage adapter. It's just essentially a annular ring that supports avionics hardware and other electronic avionics and ordnance hardware for separation and control of the first stage. And then the second stage, and then the third liquid upper stage will be delivered from Michoud, Louisiana, at our facilities there. And there's a little bit of processing once it's received here at KSC. We'll bring it to any one of a number of facilities for loading hydrazine propellant, and then that will be as well delivered to the VAB transfer aisle, lifted up over into High Bay 2 on the stack, on the MLP stack. So everything will ultimately be delivered to the VAB transfer aisle, just like it was for shuttle program, just like it will be for SLS, the NASA's SLS program, to be stacked onto the OmegA launch vehicle, and then ultimately the encapsulated payload, which the payload. There's a number of payload processing facilities, depending upon if our customer is commercial or it's a U.S. Air Force customer.
For the viewer or reader who's never heard of OmegA before, and this will be their first exposure to it, okay? What's like one of the most ambitious missions or applications that the rocket will be used for that the person at home could get excited about?
Yeah, I can't talk about the missions at this point, just because we're working with our customers on that. But it's the technology that's going into it. It's evolutionary technology with our solid rocket motor segments. So it's just between the lift capacity and the size of the payload fairing, it's able to accommodate all of our U.S. Air Force customer needs and with margin, as well as the commercial marketplace that we're going after. So these are your standard low Earth orbits, geosynchronous orbits, geotransfer orbits.
Obviously, you think there's enough business to go around then with space program like this, as long as it's not overly saturated. You can do
That's
it.
right. Yeah. There's other programs I can't talk about, but we're really excited. You know, Northrop Grumman has won some other recent contracts that we're looking forward to offering launch capability to those programs as well.
From rollout to liftoff, how long are you anticipating OmegA being on the pad for?
Anywhere from 3 to 5 days. Because there's always a learning curve with these. Well, as our objective is by the time we kind of reach a steady state, so 5 or 6 missions into it, it may be as short as 2.5 to 3 days between leaving the VAB to when we're T0 liftoff of the OmegA rocket.
They said that the heavy version would be 100 feet higher. Can you describe how that's going to look different? Is it?
Yes, it's as I mentioned, it's all in the first stage. The first stage will either have 2 of the solid rocket motor segments they're manufactured, delivered from Utah, or 4. So it'll have the heavy configuration will have 2 more solid rocket motor segments in that first stage, and then we have the option with of anywhere from 0, as our Vice President Ken Rominger said, from 0 to up to 8 solid rocket motor strap-ons. So that's the GEM 63XLTs.
How exciting is it to be part of NASA history? 39B and the VAB and everything?
This is really exciting. Yeah, I mean, I've been out here for 31 years. A lot of programs, when the shuttle was flying out, we never envisioned it would come back to life like this here. With, at the time I was working for ATK, we had a lot going on commercially, but how it's, what's happened over the last 5 years, not only with Northrop Grumman but our competitors, is really exciting. I know the whole local community is excited about it, and I think it's actually grabbing the attention of the entire nation.
Obviously, you've hired people that are doing the work now.
Yes.
What are those numbers, and how many more people will be working here?
So we are, so we have contractors for the non-recurring work, right? The design and construction. We're using primarily local firms. BRPH is our main design firm, and then we're using JP Donovan Construction. They were very instrumental in the construction activities for NASA's Artemis or SLS mobile launcher too. So we're expecting those the transition through the construction and testing to be as many as 350 short time employees, be in the crafts, the iron workers, the pipe fitters, the electricians.
Okay, so when that's done,
We gotta cut it up for
Yeah,
the
okay.
next bus arriving.
but when that's done, what is the number for the? folks
In
that
terms
will
of
be-
recurring operations, we're still working that out. So we will be staffing up significantly.
Okay.
Thank you so much.
All right, guys, so that was the second part here. So as you can see, the MLP behind me. So big day for Northrop Grumman. The big takeaways, aside from the official handovers or ceremony handovers of the MLP and the VAB, are the 2021 anticipated first flight of the OmegA rocket. And that its critical design review was completed earlier this week, and that's a huge phase for any rocket development. So that's all for today from the Kennedy Space Center. Check back later for more updates on OmegA.